Okay.
We are very pleased to introduce Professor Miquel Costas, that is here in Padova as a winner of the Gonzalez Chamichan Lectures 2023, and also he gave a seminar in the series of Frontiers in Chemical Sciences. So today we are here also for asking some questions to Professor Costas, for our student, to inspire our future chemists, let's say. And then the main first one is an inspired question: what is the most promising future direction and research prospects in the field of bio-inspired oxidation? This is a field of research that could lead to significant discoveries of innovation, innovative application.
Well, I think that in general, everything that is related to the selective functionalization of strong CH bonds, and for example, arenes, I think those are important projects or important targets for the future, basically because those are problems that are not solved. The last years what we have seen is the number of studies on trying to develop methods that allow you to functionalize CH bonds, but in the end the main problem that has to do with selectivity has not been solved. And until this is solved, I think that this remains as a very important target, because if this will be solved, I mean, chemistry will be really revolutionized, because you will have, I will say, multiple paths that will open for very simple compounds. Yeah, and then this applies to all of those. As I say, those are problems that are very simple, but probably maybe because they are so simple, they stand unsolved because they are the most difficult ones.
Very difficult one. Yes. I agree.
Mm-hmm.
Okay. Yeah.
So we can have a second question for you, and my question is about this dilemma. So nature has taken a long time to evolve this kind of enzymatic catalyst, okay, billions of years of evolution. Okay, and so we tend to think that nature can always do better, right? Here, in your seminar, is inspiring because we want to mimic, this catalytic perfection. Do you think that at a certain point we'll also be able to make a better job than nature in these oxidations?
Well, I will say that we will make a different job. Okay, for example, let me see. We think about nature as a tool that makes reactions with extraordinary selectivity, but also there are reactions that are almost impossible there. For example, when you go to very strong CH bonds, using my topic, you have a hard time finding an enzyme that can do that. And when they do that, basically what you find is that they degrade very rapidly. So my point is that probably there are a number of paths or a number of fields where nature will do always much better than what we do in terms of design of reactivity. But there are also reactions and systems problems where man-made small molecule catalyst, or I will say non-natural catalyst or non-natural chemistry, can perform better. And this applies to oxidation catalysis, but think about, for example, metathesis of olefins. There is no metathesis of olefins in nature, yeah? And it's an award-winning reaction that is being used everywhere. So nature can be a starting point for inspiration, if you wish, but I think that we can use the brain to go farther away, right? Oh, I think you believe the same.
For sure, we can understand and learn from nature, and then be complementary also to nature in many aspects.
That's it.
And chemistry is one discipline that allows us to understand and then to replicate and maybe to go beyond.
I completely agree.
So thank you for being with us.
It was my pleasure, my big pleasure.